Alrighty friends, we are going to just kind of go over measurements. I'm not going to consider this an official video going over sinus rhythms. We will get to that. We're not there yet. We're still kind of talking about this graph paper, okay? So it is calibrated to about 10, okay? We got that 2.5 boxes, and then this is over time. So one thing to note, depending on where you work, you might have a different type of a cardiac monitor. So some systems, like the Zolls, they will print out a 6-second long strip and then all of the rest of your views, depending on how it is set up. That's how it was for the one that I used to work with, okay? Now that being said, so you want to measure out your atrial rate, your ventricular rate, how long your QRS complex is, how long your PR interval is. Those are all going to be things that we're going to be measuring out and considering before interpreting a rhythm and saying, oh yeah, it's normal sinus rhythm, when it really might not be, okay? Or you might see something wide and bizarre, whatever. So we're going to use measurements for parameters to decide what rhythm we're going to say that it is or interpret. So when you print out that 6-second long strip, this is the fast way to try and figure out what your ventricular rate is going to be. This obviously is not a 6-second strip, but if you take a 6-second strip and you count your R to R intervals, because we know this is the QRS complex, that should be hopefully mechanically felt in a pulse, right? So 1, 2, 3, let's say we had 6 of them, we're going to multiply that by 10, and whatever that number is going to be our fast heart rate, okay? So let's say that there are 7 on our strip, then it's going to be 70 beats per minute, or 80 beats per minute, or 90 beats per minute. That is just kind of our fast way to try and figure out how fast their heart is beating. The most accurate way, so there are technically 3 ways, but we're only going to go over the 2 important ones. So that's that 6-second method where you're just figuring it out really fast, and then the most accurate way, which is counting these little boxes. We remember each of these are 0.4 milliseconds, so we're going to count them out, okay? Let's say there's a little bit here and some here. So we're going to say 1, 2, 3, 4, 5, 6, 7, 8. We're going to say 9 boxes in total because it cuts into those. 9 boxes, okay? So the most accurate way is going to be counting out all of these boxes between all of our R to R's on our strips, and then taking an average of that. Like, let's say some of them have 7, some of them have 8, some of them have 9, but realistically it's going to be like 16 or whatever, 16, 18, 20, whatever. You are going to take 1,500 divided by whatever that average was. So I'm going to take a calculator. Okay. So we're going to take 1,500 divided by, let's say there were 18 boxes between each of our R to R's. Divided by 18 equals a heart rate of 83, okay? Okay, so that being said, the other thing that we can do is anytime that there is one of the big boxes with 20, or like with technically 5 of the little boxes in it, we can go 5, 10, 15, and then just count the little ones, 16, 17, 18. Okay, 1,500 divided by 18, our heart rate is at 83 beats per minute. Okay, so that is the fast way to determine our heart rate. Here is a little, I don't like the 5 method, but yeah, so we can take this, divide it by 10, okay, we're at 150 beats per minute, okay? And that's going to be how we measure that rate. Okay, let's go back to this. Okay, so certain things will make up a sinus rhythm. We want to make sure our rhythm is regular, so our R to R's are fairly regular. our rate is between 60 to 100, right? So our rate will be different for different people. So let's say you have a really conditioned athlete who's a swimmer or a runner. So like me, I do kettlebell sport and powerlifting and strongman and things like that. Next month I'll be competing at a world championship in Moldova. And as I get closer and closer and more conditioned, as I sleep, I can look at my watch and my heart rate might be 42 while I'm sleeping, which is okay for me because I'm getting conditioned and my heart is using oxygen really effectively. But your average Joe walking around, like our sinoatrioventricular intrinsic rate is 60 to 100, they're on average going to be at about 60 to 100, okay? Unless maybe something's going wrong, they're tachy or they're Brady. The important thing with bradycardia too is we want to make sure that they're actually like experiencing symptoms. That's when we're going to kind of start treating it, right? Okay, so we want to make sure our rate is regular, our regularity for our R to R is regular, and then something that we're going to start measuring are the intervals and segments, okay? So the big one that we're going to look at, we want to make sure that our P wave is upright because of our rules of electrical flow as it shoots down from the top of the heart from the SA node and goes down, we create that positive deflection. So we know that this is a sinus rhythm because we have our upright P wave, and it's of a good shape. It's not notched, it's not sawtoothed, it's none of those. It is an upright and normal P wave, okay? So we know it came from up there because we have a positive deflection. Okay, so our P wave is good, and then we want to check out our PR interval, which is from here to here. We'll measure that out. Okay, so we have 2 boxes, 0.4, probably about 3 boxes in total. So that would be 0.12 milliseconds. And we'll look at the other ones too, because once those get prolonged, we know that the conduction is just taking a longer time getting from the SA node to the AV node, because that's kind of what it's measuring. So it's in a normal parameter. We want it to be between 12 and 20, so we're right at 12. We're good there. And then we're also going to be checking our QRS, which is probably, I would say, about 8, right? Like a little bit less, maybe 0.6, but 0.08 milliseconds. And we want it to be a QRS of less than 0.12. So our QRS isn't taking a long time, so we know there's no delayed conduction. Everything's working beautifully. Our rate is good. Nothing's like elevated or looking ischemic, which we will go into later. I'm just kind of dropping the seeds there. We did our most accurate thing. We had like 18 boxes between, right? Not 9. Yeah, nothing's wide and bizarre. So that's kind of the basics of what we're looking for. We're going to be measuring out intervals and making sure that they fit the parameters for a normal sinus rhythm, which we will go into more depth. We just kind of wanted to touch up on the paper and how to use it and why.